Okay, so we'll start again. I'm going to fill in right now. We were expecting Aditi from Google, who's also a Cal alum, to show us a tool called WordSeer that's really great for text exploration. Turns out she had to interview someone for a job, no doubt some data science undergrad who's going to make more money than all of us as soon as they get the job. But I'll fill in by talking about another tool that's really useful for textual analysis, one that I've been developing here with the Goodley Labs and the Berkeley Institute for Data Science over the last few years. The tool is called TextThresher, and yeah, I'll dive in. So a lot of people have an issue where they have thousands of documents, maybe tens of thousands of documents, millions of documents. And then within those documents, there's all kinds of variables and attributes they know are interesting that they want to extract from the documents. But unfortunately, at the moment, even though we've seen a lot of really nifty computational techniques to extract useful information, the algorithms can't quite do everything. Going back to John Moore's talk at the beginning of yesterday, and I don't quite have the geometric kind of pictures that he has, but the social world is very complex. And this is my model of interactions between police and protesters during protest events. So we have variables at the level of the city. That's one of our units of analysis. And then we have actual individual people taking actions. And you see them linked here because they're interacting. So it might be police push a protester who pushes back, and that's just a two-part chain of interaction. And that's occurring within a single event, this yellow circle, that might be a demonstration or a march. But those demonstrations and march themselves are linked into a campaign, and all of that's happening in a city. So a very complex picture with multiple layers of units of analysis that themselves may actually be linked. The social world is complex, and all of that is somehow or another described in our textual documents, but computers aren't really quite ready to find all that information and keep it linked as it is in the social world. Computers also, they don't find the events, they don't sequence the actions that are occurring within the events as described in news reports, for instance. They don't recognize metaphor very well, and though we're getting better at analyzing sentiment and sarcasm, the computers aren't quite there yet. There's a lot of things that the computers can't recognize. They don't see the social world the way that we social scientists see it. There are some tools out there that people use to read through documents and label them. And they can do it by themselves or maybe with a team of undergraduate assistants. And they're trying to apply some kind of conceptual scheme to the documents. It's a difficult process, and none of those tools are actually built so that you can have a large team doing the work. What TextThresher does is it takes a content analysis job and it turns it into an assembly line of work that people can do through the internet. So instead of having a dozen undergraduates who work for a semester or so and then graduate or quit and go play Ultimate Frisbee, you can have hundreds of people doing the work of content analysis, little pieces of the job spread out across the internet and doing jobs in a matter of months that used to take many years or a decade. So we're using this right now on a project called the Deciding Force Project, where we're trying to understand the factors that are decisive in creating force or violence between police and protesters. We're looking at the Occupy movements of 2011 because there were 184 different movements across cities and towns in the United States, all with very similar claims and tactics and goals, but facing off against different cities and police departments. So it's an opportunity to learn a lot about how cities and police departments engage with movements that are fundamentally quite similar. So this is a picture we're looking to find in our data. If we look at some of the current kind of competitor projects on protest and policing out there, we can look at GDEL, Global Data on Events, Language, and Tone. This is their model of reality. So we don't have a picture of the actual individual actions that compose an event. We don't understand by their model how the events are linked into campaigns, and we don't actually have a very good resolution geographically. Instead of looking at cities, they're only able to look at the state or regional level. Now there are some other projects. The Dynamics of Collective Action project did a lot of hand coding, reading through newspaper articles, and they were able to recover a pretty decent model of police and protester interactions, but they're not able to see how actions are interlinked within events, or how events are linked together into campaigns. And they can read that, of course they read that when they're reading through the newspaper articles, but to have all of these undergraduates code everything at that level of resolution, it already took them a decade to do this. So to get the more complex picture, I don't know what that would take me, 2 or 3 decades. So we're doing this through TextThresher, and the way that we break it down into an assembly line is mostly, for this project at least, through a 2-step process. The first thing people do is they read through an entire news article, and they're just going to highlight text units that correspond with these yellow circles, the unit of analysis of an event. So that's how they start. The first step is to read through and find protester-initiated events, or to find police-initiated events. We also have them look for units of analysis like what the city is doing, or what's going on at the encampment. So this is a when it comes to cognitive complexity, this is a job that people can handle. And we had a team of 12 undergraduates read through 8,000 articles and in a single summer, and tag all of these articles at this high-level unit of analysis. So that gets us our yellow circles, and a little bit of like classic spreadsheet data munging gets us this orange circle here, what's going on in each city. How are we going to get in to those little white circles of the actual activity? Well, what we do next is we take a text unit that's just about one of the protester-initiated events, and we send it to someone in an interface like this, where we ask them to do essentially a reading comprehension quiz. Who's taken a reading comprehension quiz? If you're not raising your hand, you're lying, because you went to middle school. And so did pretty much everyone else out there in the population. So we're not training people in a completely new, weird, esoteric task. We're asking them to do homework that they've already done thousands of times in their life. The only thing that's a little different than the classic reading comprehension quiz is we're asking them to highlight the words that justify their answer. So if I ask them a bunch of questions about the variables and the attributes that are important to me, that are important to my theory of protest and police interactions, and then I ask them to justify their answer by highlighting words, they're putting labels from a very complex scheme onto those documents. So whereas the other kind of qualitative data analysis software that I talked about, they typically recommend that your coding scheme, your conceptual scheme, max out at about 30 different variables. In my conceptual scheme, we have over 200 variables. And we're able to do that because we can break the task down like this, and we can also ask follow-up questions based on people's responses to particular answers. Let me show you what that looks like. How am I doing in time?
7 minutes.
7 minutes. That's luxurious. Okay. Well, here's the first thing. I want to show you this interface here. So here, I have someone reading through one of those text units. It's about a single protester-initiated event. Can we read this, or can I make this bigger? Let's make that bigger. So the first question, we have a question queue here. And depending on my answers to the questions, it's going to build out more questions. So I can get follow-up questions. So the first one says, what kinds of subtopics, what kinds of information appears in this unit over here? And if I say there's information about a protester-initiated event, like the activities or setting, you see that I get 2 new questions. If I say that there were police activities, or other than arrests, or arrests and injuries, you can see that a question queue is building. And as I move on, I get asked more specific questions, like, was this a demonstration, a strike, a march, or parade? Let's say it's a demonstration. I get this inkwell that says, oh, I need to go ahead and highlight and justify my answer. I move on to the next question, and again, it's asking some more detailed, what does it say anything about the location, or the date or day of the week? For this one, apparently I need to highlight a particular word. Let's pretend that says Friday. The number and or kinds of people who attend. It's all building in the question queue additional stuff that I need to go ahead and find. So I said that there was information about the location, and now I can choose among, well, was it at the local park or downtown? And again, justify my answer. And I keep moving through this until I've gleaned from that text unit everything that could be interesting to a researcher about police and protester information. When we have people do this, we don't just have a single person do it and take their word for it. I mean, even though people are pretty smart and they're good at reading English, and we write all of these questions in a common sense way so that we don't have to train them face to face, we don't quite trust their answers. Who's going to help me get out of this screen? Is there a special way to get out of the screen besides just tapping escape? Here we go. Here we go. Nope, that's not the one I want. So I want this one, but I don't want to be stuck in here. There we go. Yeah. It's like this talk was just invented on the spot just a second ago. Okay, so what we do is we take information from multiple different people. I would have sent that same text unit to about 9 different people. And if 7 of the 9 agree that for each individual item, then I take that data into my database. If they don't agree, you know what I do? I send it to more people until it's 9 of 13, or it's I can set those thresholds however I like. And if the data don't agree at all, and we can kind of look at it and see, is there actual real confusion here? Is there misreporting, or do we need to change the way that we're wording our questions, et cetera? You can also look at the biases of the people out there in the crowd. So if you have people from the internet, you can kind of start to see over time that some of them might be biased towards the police or biased towards the protesters compared to others. You can give them reputational scores for if they're agreeing with a lot of people all the time, then their reputation in the system should go up, because however they're seeing the world seems to be the common way that people are seeing the world. So we can, from this sort of system, not only, I guess I want to pause and say one thing about epistemology. So whether you all know it or not, the way that you know things in the world is because you're checking in with other people. This is what we might call a social epistemology. There is no objective truth that we can actually grasp. But we all have our subjective experience, and then we have our intersubjective validation of what we're seeing in the world. What TextThresher does is it takes that intersubjective social epistemology and it formalizes it into a tool where our understanding of reality is something that we can actually label onto a document and we can compare with each other, and then we can show to anyone in the research community or anyone in the world, this is how we came to an understanding about this particular document. It was because Tom and Sally and Joaquin and Heather all did this work, and they agreed that this particular set of words means this is a demonstration, or this was a rally, and it wasn't a candlelight vigil. So we can do all of that, and we can do it openly, so that the review community and the whole research community can see what we're developing. In addition, that's one virtue of having these labels and having them open. Another thing we can do with these labels is we have incredibly intricate training sets for machine learning algorithms. So one of the things that's kind of been an undercurrent or a theme in some of the talks is that the data you put into your algorithm really matters, whether it's making sure that you have the right kind of word partitioning, or making sure that your data are representative of more than just some majority kind of opinion or perspective in the world. If you want to have really solid data at the end of your algorithm, you need really solid data going into it. You need these representations of reality, these more dynamic and intricate representations of reality being fed into the computer that's going to learn then how to look at your documents and let you know what is in that reality. So the way we see this going is that TextThresher is going to be a tool allowing social scientists to specify their theory of the world, get help from people, citizen scientists, people out on the internet, to label up all of these documents. And then we actually build particular artificial intelligences that are able to say, look at protest documents, look at legal documents, look at the sorts of speech that's happening online and social media and elsewhere, in such a way, in the same sort of way that a really top-tier sociologist would look at So this tool is right now, it's under beta testing on 2 different projects. The Deciding Force project, which I just showed you, and another one where we're having people look through the news and find evidence of misinformation, like inferential mistakes or argumentative fallacies, so we can kind of get our hands around the fake news and misinformation problem. Those are the first 2 projects, and those are both happening here at BIDS. They're both in combination with the Goodley Lab. And we are eating our own dog food, and it tastes okay, which is not something I often say about dog food. It's pretty good. But if you would like to use this software, this is what I asked you to do. Some of you've heard a little bit about this and you're interested in it. Send me a very enthusiastic email. Tell me exactly how you want to use it. And I can do a couple things with that. I can put you at the top of the list for who's going to get to use it first, but I can also shop it around to some funders and let them know that there's real demand here, as I think there should be. So shoot me an email at nick@goodleylabs.org, and I need to hand the mic to someone else now. Here you go, Martin.